We will do some exercise about the timers today. First of all, we have to know something about the timers. For example, to do some settings, we'll use this kind of block diagram for the timer or counter. This is given for the TC0 and it is given for the TC1. And also we know that we have some mode to use the timer or counters, and all of these modes is given in this table. Mode 0 is 13-bit, mode 1 is 16-bit, and mode 2 is 8-bit auto load mode. What about the timer counter 2? We will do setting by using the T2 cone for the timer or counter 2. And also we have another table for the mode selection. As you see here, we will use as timer 2 as 16-bit auto reload mode and also 16-bit capture mode. For the auto reload mode, this part is the same. CT bit, as you know, is the selected input source. It can be oscillator periods or external logic signal. TR bit is the activation bit for the TC. Uh, for the auto reload mode, as you see, we will load the initial values with the overflow and also the external side. So you can do this operation in two ways. Yes, to set the initial time values for our microcontroller, as you know, 12 oscillator periods are equal to the 1 machine cycle. It means if you use 10 megahertz crystal, so 1 machine cycle will be 1.2 microsecond. Okay. Uh, Machine cycle is important for us because in the timer mode, uh, the counting value actually machine cycle. Okay. Because of this, it is so important for us. Yes. What is the application? Write the 1851 assembly program code which flash the LED connect to the port 2.0 at interval of 0.72 seconds using TC 0 and mode 1. Okay, what is mode 1? Mode 1 is 16-bit. We know this from the table. Mode 1 is 16-bit. What is the input source for this question? It can be timer or counter, right? What is input source for this question? It can be timer because we need a time interval for this question, not count any external signal. What about the start stop operation? It will be from external world or software. In this question, we didn't see any information about the external signal, so we can say it will be software. After know this information, you can do your T-mode settings. For this question, we will use TC0. It means the high nibble of the T mode is related to the TC1, so it will be 0000. What about the second nibble or the first nibble, the low nibble? Low nibble is related to the TC0, so the third bit of the T mode is gate bit of the TC0. We know this, we will use software. Maybe we can show you block diagram in here. Gate 0 should be 0 for the software because it is if gate 0 is 0, it will be 1 and the output of the OR gate will be 1. When you activate your TR0, the counting value will be start, not depend on the external signal. So gate 0 should be 0. What about CT0? This is the input source selection. It can be 0 for the timer, because if you choose 0, disable this path connected to the external word, it means counter. But in here, activate this buffer, so oscillator period will be count. This is timer. So it is 0 and 0. What about the mode? Mode 1. For the mode 1, 0 and 1. After knowing this information, we can write 0, 0, 0 and 1 for the T mode. What about the timing value? How can we set the initial time values? We know this in the timer mode. Actually, we count or timer counts the machine cycle, and each machine cycle is 1.2 seconds. But we need for this question 0.72 second. It means 0.72 over 1.2 microseconds gives the machine cycle needed for this time. So we'll use in here, we'll use a calculator with the conversion between the units. We need 600 and 1000 machine cycle. We need to do 600,000 machine cycles. So how can we do it? Because as you know, in our timer in 16 bit mode, we can count only 0 to 6, 5, 5, 3, 5. So how can be possible? How can it possible? Maybe we can do this operation many times. If we set a loop and if we check the value of the overflow flag, we can do this operation. I mean, if we divide the needed machine cycle to our machine cycle, we can get a number. Yes, it will be 9.155. It means that if we do 9 exact overflow and also 0.155 initial value for the machine cycle, and then we'll get 60000 machine cycle. Okay, we can do this operation as like that. Okay, so to do this, we need 10D overflow. Okay, and also I said before, we need the initial value here. This initial value should be times, it gives we need to do 10 and 158 machine cycle also. Maybe we can I can try to explain again. We need 9 overflow, exact overflow, and also we need to do also 10,158 machine cycle. Okay, so it means we need to load initial value, the maximum value minus our machine cycle. It gives the initial value. It is as like that. Okay, now we found our initial value and all settings. Now we can write our micro program. Okay, let's do it together. First of all, we need to do settings for the timer. We'll use T mode. Move T mode. It should be 01 hex. Then we need to load an initial value. Maybe we can do this operation by using the subprogram, because maybe we can need another line, another program line. Okay, for this reason, please do this in a subprogram. A call settings, maybe you can try to write. Okay, and then in this program we did all of this timer settings and loop. Then we can try to start our microprogram. Set bit TR0 for the TC0. So we should check the overflow flag GMB TF0 and wait. If the TF0 value is 0, please wait in this line. If it is 1, the next command line should be clear TF0, as you know. And then if we have a loop, we should use this loop. Okay. I will explain in detail to you. Move dptr and what is the value, initial value. Okay, and then move tl0 dp low, move th0 dp high, and also we need a loop. Maybe we can use R7 for this. R7 should be 10 decimal. Okay, then we can try to continue. Clear TF0, and now we should check the loop counter. Okay, B, J, and Z R7, and if it is not 0, we'll go to the wait label, because it's mean now we don't have enough time. If you are in this line, it means 0.72 second is passed. Okay, but in here we know this. We did only one overflow, not all of that. Okay, and then if we are in here, we should do our operation. What is the operation? CPL port 2.0, and then we need to load initial values again. Okay, so we need to load this value and this value again. Now we can try to write a subprogram here, equal settings. Yes, I'll cut follow this line and equal settings. As you see here, we need two types in the program, and then I will pass here and label settings. Okay, then we need a ret command for the subprogram, and also we need here a unconditional branching command because we don't want to enter in subprogram without any invoke. Okay, so let's jump wait. Let's check this program again. This is the setting for the timer 0 TC0 16-bit timer and start with the software. This is the initial value for the 0.72, and a call setting in here. We will load the initial values to the counter and then count register, and then this is a loop need for the time 0.72, and then we will turn back. Set with tr0 means activate tr0, and we will wait the overflow, clear overflow, and check the time. If it is enough, then CPL port 2.0. For the next loop, uh, load the initial values again. Okay, and let's jump wait. We'll wait again. Okay, maybe we can try this program in the debug session, and we can check the time exactly it is convenient or not. Yes, in the peripheral part, you can get your timer. We'll use timer 0. Okay, let's do this program together. Step with the step function, t mode 0 and 1. It means we can see here 16-bit mode, and now for now th00, tl00, and t mode 01. Okay, and tr0, as you see here, now 0. Gate 0, int is not important, and overflow flag 0. Yes, move dptr, this is the initial value, equal setting, load the initial value, and now you can see the initial value in the counting register, the 8 and 5 1. And then we will turn back and start the program. We will wait here, but you can pass the time value, inserting a breakpoint here. In this line, we know this 0.72 second is passed. Okay, we can check it now. In here, we have second value, the time value, and also in here we have a time value. Let's check it. Yes, as you see here in this line 0.72, and if I click one more time, it will be 1.44 and 4, right? Let's check it. Yes, as you see, and 2.16 and blah blah. Okay, so we can say it is now convenient for us. But please remember that to do this, we assume that one machine cycle 1.2 microsecond. It is possible for the 10 megahertz crystal. So you can do your setting according to this. Okay, in the program. In the program, as you see, target X12 value 10 megahertz. Maybe we can check it in the Proteus model. Yes, let's check it. Load the hex value, hex file, and okay. Yes, as you see, the LED flashing in the time interval 0.72. Let's continue with the next question. Write the problem given in step 1 using TC1, timer counter 1, and mode 0. Mode 0 means 13-bit. So, for this question again, input source timer, mode selection not 16-bit, it will be 13-bit, and start stop operation is does not change, so it will be software again. What is the T mode? Mode 0 means mode 1 and mode 0 will be 0 0. Okay, so T mode should be as like that. And what will be happen now? We need again the same machine cycle, but the counting value limit is changed. It will be 8, 1, and 9, and 1. So we have to do this operation according to this number 8, 1, 9, and 1. Let's do this with the calculator. Yes, we need to find the new number for the loop over 8, 1, 9, and 1, and 2 also. Yes, we need, as you see here, yes, we need 73.242. What does it mean for us? We need 74 exact overflow, 74D overflow. And also we need the initial values for this question. We can find how. In here we have a problem. As you know, for the 13-bit, we can use only the low 5-bit or the TL register. So it means for each 32, one increment will be added to the TH register. Maybe I can show you here. For the 13-bit mode, every 32 division coming from the THI value. So it means we have to consider this fact for the calculating in this question. It means 0.24 and 2 times the maximum value 89 1. This will be what now? Yes, it will be. We need also 1982 machine cycle. We will do 73 exact loop, and also we need 1982 machine cycle. So we need to load initial value, and initial value should be minus with the maximum value. Yes, it will be as like that. Yes, here how can we load this value to the register, counting register? This is a problem for us. If you know for each 32 value, one increment will be added to the TH register. We can say this, if we divide this number to the 32, we can find the TH value, real part of this, the results, the real part of the results is will be TH register. Okay. Yes. It will be 1, 9, and 4.0031. So the real part will be TH. The remaining part will be TL. How? 0.031 times 32. It will be approximately what? Yes, approximately 1. TL0 will be 1 decimal. Now we can write our program modifying this. Yes, move T mode 0 and 1. It will be 0, 0. Sorry about that. We should write this program according to the TC1, not TC0. So it will be TH1 and TL1. So here 0, 0. We don't use dptr. Echo settings. TL1 will be 1 and TH1 will be 194 decimal, and the loop will be 74D and the rest. Then we should activate the TR1, TC1, and we will check TF1, and clear TF1. The remaining part is the same. Yes, we don't have any warning or error. Let's check first in the debug session. We don't use timer 0, we'll use timer 1. And then step by step, as you see here, 13-bit timer counter, and the initial values is loaded again, and activate this. If we are in this line, it means 0.72 second is passed. Yes, as you see here, 0.72 passed and 1.44 and blah blah. Okay, we can do this question as like that. Maybe we can try on the Proteus model. Let's check on this Proteus model again. The same text file, and we don't have any problem here. The next problem is the same, but we'll use mode 2 and TC1. Mode 2 is 8-bit auto-reload mode. Okay, let's copy this part on here. We'll use timer, but not 13 bits. We'll use 8-bit auto-reload. How can be possible? Start stop with software, yes. Mode selection. Mode 2 means it will be 1. The remaining part is the same. Sorry, 1 and 0. Mode 1 is 1. Mode 0, M1 is 1. M0 is 0. Okay. The remaining part is the same. With the software, timer, and mode selection. That's all. We need also the same machine cycle, but the counting value now 0 to 255. So we have to find what we need now. But here there is a difference from the others, because for this mode we load a value, and each time the same value will be loaded on the counting register. Okay, maybe I can try. I can show you on the lecture notes. Yes, in this mode we have an initial value, and this initial value is loaded to the th1 or th0, not important, and for each overflow the initial value is loaded again to the counting register. So it is the difference from the other. How can we do it now? For this question, we need to know a number between 0 to 255, and we will times with a number, and we will get the needed machine cycle. Okay, we have to find this. So we can choose a number in this interval according to this number, because we want to set x value an exact value. Okay, only real part. So maybe we can do this number. We can choose 250, right? We can choose for this question 250, and then we need to know now x value. How can we know? By dividing this number. Yes, divided by 250. We need 2040 400 loop. How can we do it? Because our microcontroller is only 8-bit. Maybe we can do this loop with the nested loop. 240 times 10. Okay, we can do as like that. Initial value should be 255 minus 250. It will be 5. Let's do this question now on the cave. Now for the T mode, we will change the value. It will be 2 now. We don't need dptr again. Echo settings, and in settings, we'll use again TC1, yes. TL1 should be 5 and TH1 should be 5 and R7 should be 240 and we need another counter now. R6 it will be 10 decimal. Okay, this is the subprogram and then start the program. Yes, wait, clear. Okay, DJ and Z R7 is not enough for us. If the next line, it means only we did 240 loop. So we have to load this value again, and then we need another control. DJ and Z are 6. If it is not 0, go to the wait. Now, if you are in this line, it means 0.72 second is passed. Okay, but now in this line, we have to set R6 value again. But we don't need to load the values, initial values again and again. Okay, we will do this operation only one time. Maybe you can understand from this figure. As you see here, the initial values is load at first to the TH1 and also TL1, because you can see here after the overflow the initial value is loaded from the TH1. Okay, so at first you have to load the initial values to the TL1 also. This is the 8-bit auto reload mode. Maybe we can try again. Debug session, insert a break section, and then go to the break section. Yes, as you see here, 0.72. Okay, and if you do this same operation again, 1.44. Let's continue from the other example. Next question, we'll do the same question with the TC2 and auto reload mode. Input source timer again, mode selection 16-bit auto reload mode, start stop with the software, and we don't use T mode for the TC2, we will use T2 con. Okay, how can we set TC con, T2 con now? Let's check it. On the T2 con, we have TF2. As you know, we don't care on the overflow. It's about the hardware, not about us. This is also with the hardware. It will be 0, 0. R clock and T clock. It should be for the 16-bit auto reload mode 0, 0 and 0. Exen 2-bit is about the external signal. If you load the initial value according to the external signal, you will set this bit. But in this question, we don't use, so it will be 0. T2 com is bit addressable, so we will start next, so it will be 0 again. CT is about the input source is timer, so it will be 0, and CP RL2 will be 0 for this mode again. So all of this 0, 0. Where is it? Yes, it should be 0, 0 hex. We need the same machine cycle, but the counting value again is like that. So now we know we should do the same operation with the 8-bit autoreload. I mean, times with a number, and we will get the needed machine cycle. Okay, so we choose a number between those numbers. Maybe we can choose 60,000, right? It is convenient because x will be real. X will be exact value. So we can choose 60,000 machine cycle. So if we do this operation for 10 times, you'll get needed machine cycle. Okay, that's all. We need to load as initial value 5,500, 3 and 6. Okay, decimal. That's all. We can do this operation now with the program. We will use T2 con, and it should be 0, 0. We will use dptr for now. Yes, it will be as like that. Okay. Echo setting TL2 should be dp low. TH2 should be dp high. What about R7? R7 should be 10, and we don't need R6 now. But also, we should set the other register. What are these? The initial values is loaded all of this time from the RCAP2 high and RCAP2 low. So we have to load these initial values to these registers. So move RCAP2 low will be DP low. Move RCAP2 high should be DP high. And then all of this operation is now finished. And then we'll go to the this line set bit tr2. We'll check tf2 and clear tf2. Check the r7 value. Okay. Load the initial values of the r7. It will be 10, and we don't use r6 also, and cpl for 2.0. For this question, now we don't need to this line again, because as I said before, for every overflow, the initial value loaded to the register. Yes, for the auto reload mode, for every or flow bit, the initial value will be loaded to the counting register. Okay, so we don't need to set again the same value to the registers. Now we can compile this program. We don't have any warning, any error, as we don't use TC1, we will use TC2. Yes, let's run this program step by step. T2 call, timer counter disabled, as you see. Okay, T2 call 00. Let's continue. Echo setting, yes, T2, as you see, the low part will be A0 now, and the high part 15. R cap value is the same, as you see from here, and this is a loop. We'll turn back and set bit TR2. We'll check in this box. Yes, now the mode timer 16-bit reload mode. Okay, maybe we'll do the same operation. We have a breakpoint here, and we will go to here, and you can check the second in this line. It is 0.72, 1.44. Okay, maybe we can check on this Proteus model again. Okay, we can do all of these operations by using mode 0, mode 1, mode 2, and also TC2.